Welcome to lesson 2. Now, just so you know, I had originally intended on each of these being a lesson for each class. So one a day. 3.1 would be Monday, 3.2 would be Tuesday, 3.3 would be Wednesday. I'm going to do a bunch of these. I aim to have the entire unit done by the end of today, in which case if you want to zoom through all of it, you are welcome to. If you want to pace yourself and do one a day, then go for it. That part's up to you. I do recommend doing the homework, so going through the lesson, doing the homework so that you have the ideas, you have the concepts, you understand them, you've had time to think about them in your head, play with them in your homework, and hopefully you've memorized a few things. Today's lesson is going to be an important one because if you don't understand the terminology that we're going to be talking about, these are the words that I'm going to be using most of the way, pretty much the entire way through. If you don't know what they mean, then you're going to be kind of perplexed along the way. So, as you've already found, a parabola looks like a giant U or a giant N, depending on whether it opens up or down. So here you see we have it as a U. Now, the graph is called a parabola. And the parabola, or parabola, as I like to call it, so remember how to spell it, has several important features. The single most important feature is the vertex. But almost as important are the x-intercepts. And there can be 2 x-intercepts, there can be 1, there can be none. Okay? There is a y-intercept, which in linear equations was very important. In quadratics, not so much. We do deal with them a little bit, but for the most part, we don't care. Now the vertex is made up of 2 parts. There is the axis of symmetry, axis, and you're frequently going to see me write this out as AOS, just because it's a lot to write. And then there's something fancy called the optimal value. Which is a fancy way of saying max or min. So what is the highest or lowest value of the quadratic? Now, as we've already seen, as we've already discussed, parabolas can open up or down. The x-intercepts of a parabola is where the graph crosses the x-axis. Now, for some reason, we give them special names. They are sometimes called zeros or roots. You're not going to hear me call them zeros, but you might hear me call them roots from time to time. The axis of symmetry divides the parabola into equal halves. So symmetry means that whatever you have on one side of the line, you have the exact same thing on the other side of the line. And if we look at the parabola, whatever happens on the left side is exactly mirrored on the right side. Now, because the axis of symmetry goes up and down, because it's a vertical line, it's always x equals. So remember last year when you were looking at linear equations, the only exception to y equals mx plus b were vertical lines? Well, here it is. And of course, x equals some number. The vertex of a parabola is the point where the axis of symmetry and the parabola meet. At this point, the parabola is at its maximum or minimum point. Now, Combined, you're going to hear me say the optimal value an awful lot because I don't want to give away if it's a maximum or minimum. The optimal value is kind of the a way to group the optimum or minimum, like without saying one way or the other. So the optimal value, oops, and don't worry too much about the handwriting. Yeah, it'd be nice to be able to copy this down right now. As you may have noticed, I'm also saving these files as a PDF. And anywhere that I find that my writing has gotten a little messy, I've turned around and changed it into text. I just don't want to do it during the video because it's going to make the video much longer than it needs to be. Where'd we go? And the optimal value is the y coordinate of the vertex. And although we didn't say it, the axis of symmetry is the x coordinate of the vertex. The y-intercept, we talked about last class. It's where the graph crosses the y-axis, and x is always 0 at that point. How to find the axis of symmetry. So any 2 points, providing we have the same y value, they should have equal, they will be equally far from the axis of symmetry. So the little circles that we have on here shows that it's the same y value. That means that exactly in the middle, we can find our axis of symmetry. So it doesn't matter which y values we choose. I'm going to use those ones for no particular reason. Our axis of symmetry can be found by using the midpoint formula that we learned last chapter. So in this case, 1, 2, 3, 4, -4 plus 0 divided by 2 equals -4 divided by 2, -2. I can divide. Once we have our x value, we turn around and substitute it in to our formula. Looks like I picked good values. Nice and easy to work with. And remember to give me that final, your vertex is, because that's actually what we're looking for. Think of it as your therefore statement. It has to be there. Just because you show me that this is the x part and this is the y part, don't assume I know how to put it together. So we're going to practice a little bit of identification here. We're going to be a little lazy and just assume that whenever it crosses the x-axis, it's an exact value. So for this graph, so we're looking at the one farthest to the left right now, right here. The vertex, and again, this is where you would hit pause to go through and try it on your own, but the vertex is 1, -3. This one is a min, y equals -3, axis of symmetry, x equals 1. Now we're being a little lazy here. Again, we're going to ignore that it's a decimal, 1, 2, 3, and we're going to call it that it's exactly on the lines, up, and in this case, the y-intercept is -2. Notice I can cheat with most of the points. My zeros, my x-intercept, I can just give the one value. I don't have to write it out as a number. The only one I can't cheat on is that axis of symmetry. It has to be a formula. I did not have to write my optimal value as being -3. I could have just written down -3 and that would have been okay. But your vertex has to have brackets around it. Your axis of symmetry has to be a formula. All right, next one. Vertex is 1, 1, 2, 3, 4. It is, this time it's a max, and the maximum is 4. Axis of symmetry, once again, is x equals 1. My zeros, actually, I'm going to be a little, this one's good enough. I can be somewhat precise. This one opens down, and my y-intercept is positive 2. The last one is a little trickier. My vertex, there's no dots to mark it off, so my vertex, 1, 1, it is a minimum value at y equals 1. Oh, I didn't realize I had all 3 of them at x equals 1. Anyways. Now you can't put in 0. In this case, it doesn't cross the x-axis. You can't tell me that there are 0 x-intercepts because 0 is a value, right? It could cross at 0. Okay, so you have to say in words that there are none, or that it's not applicable, or something along those lines. It does not cross. However you choose to phrase it, but it cannot be a number. And the y-intercept is 2. That is all that I have. The homework is to be found on the handout. The answers are there. I believe they're included with the handout, but if not, then I definitely posted my hand-on answers. That's it for today. Have a good one.